If you've ever been in a lab, you've probably seen one of these. This is a completely ubiquitous tool that you should have in your pocket if you're a lab kind of person, and it's used all over wet labs, that is, chemistry, biology, biochemistry, anything that involves liquids. It's very easy to use. You simply take this strip of paper and dip it into whatever liquid you have, and you see the color, and that corresponds to a pH. Now, the compounds in this that allows for this to happen is called indicators, or pH indicators. Any compound that can change color due to acid and base properties of the solution are called an indicator. And in this paper there's usually a mixture that gives this range of colors. Most compounds will only have one or two. Now, litmus was the first commonly used of these pH indicators. It was a binary, red to blue, blue to red thing, if it was red in acid and blue in base, I think, with a transition somewhere around pH 7. Litmus has the problem that it's extracted from a lichen in Norway, mainly, and it's quite expensive. So it was pretty pricey. And of course today you have a lot of synthetic dyes in this. But the other very early and very simple pH indicator that a lot of people are introduced to is red cabbage juice. This is like a show chemistry kind of thing where you you boil some water and extract some red cabbage leaves, and then you get like this red suspension, and it changes color like 5 or 6 times because the anthocyanins in it gives a range of colors. And it looks very nice. Unfortunately, cabbage juice is garbage as a useful pH indicator. You need a very concentrated solution to see the colors, and it's not stable in air, it decomposes over time, and it smells like cabbage. But there is another very, very simple, very, very cheap, and very, very available pH indicator that has largely been forgotten by history, and that's turmeric. So, turmeric, which today can be bought everywhere, 100 years ago might have been a little more expensive as an imported spice, but still pretty available. And in that is a compound called curcumin. Now, curcumin, there are a couple of similar curcumins. Chemically, curcumins has this 1,3-diketo system that can swap between enol and keto forms, and this gives this pH color swap. And it's quite striking, and it's quite good. There is actually precedent for this being used historically. Now, in Salomonson's Conversation Encyclopedia, which is like Danish Wikipedia from the 1930s, it's like an encyclopedia that's just surface level, so you can sound smart in a casual conversation kind of thing. They have an entry on bases where they say something like bases turn the red litmus paper blue and the yellow curcuma paper brown. Now, the fact that that's like the definition of a base in this very, popular science kind of encyclopedia suggests that it was a common thing that people used, like as a pH paper, and it works brilliantly. So I thought I would try to recreate that. So doing a crude extraction of the curcumin from turmeric is fairly easy. We can weigh out 10 grams of the curcumin. Sorry, we can weigh out 10 grams of the turmeric. Yep. Right, approximately 10 grams of turmeric. To that we can add approximately 20 milliliters of ethanol. Again, I'm doing this like almost by eyeball, simply because it really doesn't matter. That was more like 30 milliliters. And we can let that settle for a while. Right, it has been about half an hour with occasional stirring of the cold suspension, and you can see that the plant matter of the turmeric has now separated out and settled to the bottom, and there's a nice bright reddish orange liquid on top. This is our ethanol solution containing most of the curcumins and whatever else the ethanol has extracted. The purity doesn't really matter here. The concentration is not that high, and we're not going to use very much of it as an indicator because it is very, very color intense. So it shouldn't matter. You could purify it by column chromatography, maybe even recrystallization or titration, but this is going to be fine for almost all purposes, unless you really, really want to. So we can decant/filter this off to get a nice solution we can just directly use as a pH indicator. I'm just filtering it through a cotton ball. It's a very, very fast filtration. And unless your solution dissolves cotton, it should be good. And if you really wanted to, you could wash the waste curcumin here, get a little more yield. But once again, the starting materials are so cheap that if you're worried about not having enough, you could just start with twice the amount. I don't know if it shows out on camera, but it actually fluoresces quite a bit under my LED light here. Right, well, let's set that aside. And here we have a nice solution of the curcumin. So if we now take a small flask of water here, and then add just a few drops of the indicator. Remember, with pH indicators, it's pretty important that they are present in an amount so little that stoichiometrically they don't really interfere with the process. If you, for example, had one equivalent of pH indicator, then if you did titrations, then you would be off by one equivalent. So this is like 4 drops. We can add a fifth. That's like 5-6 drops, and you can see it's a fairly strong color actually. And this is the acid form, and we can see this by adding a milliliter or so of base. This is 1 mole of sodium hydroxide. And you can see it turns very dark red. This color resembles the concentrate over here. I don't actually think that's pH dependent. You can't really count on these things in solvents that aren't water, so I think that's more because it's very concentrated. And just to reiterate that this actually is a reversible process, let's add a little bit of 2 molar hydrochloric acid to see if it will return. And lo and behold, it does. Now, at some pH, you see that this indicator is actually slightly turbid, so there is some solubility thing going on, but I don't think it matters hugely. And let's add base once again. There it was. So that's it, back and forth, and it is actually a fairly good pH indicator. Now, the original historical document said curcuma paper, and indeed making indicator paper with it is fairly straightforward. If we take something that is stain-proof and take some thick paper, this is something like filter paper, it's actually chromatography paper, but it's almost the same, we can in principle just pour a little bit of solution on. If you wanted to mass produce this paper because you wanted to use it, you would probably want to do it on, if you wanted to make more than one of these leaves, then you would probably want to, have a little tank where you can dip them and then just a little rack where you could dry them. But I'm really just interested in showing you. So. Right, as you can see, you now have a very, very yellow piece of paper. I'm going to refrain from touching it because, once again, this color is very intense. And dry this, then you can just cut it up into little strips and use it as pH indicator. Right, that was about 2 minutes. The paper's almost dry. The ethanol works pretty quickly. And as we can see, once again, sodium hydroxide, 1 molar, and you can see that the reaction is pretty remarkable. Well, there you have it. Homemade pH test paper. That might be useful. Maybe it won't. Either way, I hope you found that interesting.